Share the knowledge and invite a friend to listen. Search Apple, Spotify, or YouTube for TechRadio Ireland.
We often talk about the challenge of getting more young people interested in careers in STEM, science, technology, engineering and math. As the job market is developing, how can universities and businesses show that they are keeping up with how young people learn and what they expect in a career? Dr. Fiona Boyle is Director of REEdI and Head of Department STEM at MTU's Kerry campus. During the week, she had a chat with Niall Kitson about the challenge of getting young people interested in an engineering career and the role of industry partners in supporting emerging talent.
Fiona, it's a recurrent debate and problem within the IT sector that there just aren't enough candidates out there to fill the amount of jobs that are in the marketplace. Is this a similar problem in the engineering sector? And if so, how does one go about rectifying that issue?
Yeah, it is definitely, it's a similar scenario we're seeing in the engineering side of things. And I suppose I'm over an initiative at MTU Kerry campus called REEdI. Now, REEdI is a project that was funded by the Higher Education Authority and the Human Capital Initiative Pillar 3 programme. And really that programme is all about delivering agility and innovation in education and to meet the skills needs of enterprise. And from our perspective, we were looking at it from the engineering talent pipeline and also from the manufacturing sector in Ireland. So when we came up with the concept of REEdI back in, it was nearly 2019, 2020, we had a founding group of companies with us, 8 manufacturing organisations from around Ireland. And that was a key issue that they were having was, filling their talent pipeline with engineering graduates. And I suppose what we did was we started, I suppose, at the ground and we said, right, well, how do we be agile? How do we be innovative? How do we do something different? How do we rethink or reimagine the way that we're designing and developing engineering education? So we looked internationally, we looked at the MITs, we looked at the Stanfords, we looked at, the leading world universities in the engineering space. And we used that as our baseline. We looked to see, right, well, what are other people doing? And then we got our industry partners together with us and we said, right, well, if we look internationally, but we have to use that best practice and bring it back to the regional context and the national context here in Ireland. And one of the first outputs of the REEdI project was engineering education framework. So it was, a core set of guiding principles that we would validate engineering programs around, but also not to stop there to look and say, well, okay, we can do this for engineering education, but can we scale this framework to other disciplines as well? So when I say a framework, okay, it's very highfalutin, but really what it means is, it's based on best class internationally and nationally. It's co-created with enterprise in the Southwest region and nationally. It has significant elements of work-based placement because that was one thing as well that our industry partners were saying in terms of their talent pipeline. Graduate engineers, they were missing certain skill sets. So we had this concept at the very outset of a well-rounded engineer. So an engineer of the future, an engineer that had the technical skills, but also had the transversal skills. And I don't like using soft skills. It means that it's easy. People skills. So it was those three things that were really important to us. So we wanted to make sure this framework gave us helped us to deliver that for the manufacturing companies. And part of that was having a significant work-based placement built into the framework. So for us, that is 2 years on campus in MTU and Kerry, but then 2 years on a paid work placement with one of our partner companies. Another part of the framework is emerging tech. So we build in emerging technology from year 1 all the way through to year 4. We might talk about that a little bit later, the integration of virtual reality, augmented reality. We have project-centric learning. So our student engineers, when they come into us in year 1, they are learning in teams and on projects from day 1. We have a lot of student-led curricular activities and extracurricular activities to help students hone those transversal skills, their people skills, their soft skills. And we have a huge arm around education, public engagement or outreach activity. And then we also have a lot of mentorship and support frameworks as well that we've built in from the outset for our student engineers. And we have a concept of engineers in residence as well. So these are engineers that help inform the curriculum. They are our conduit between academia and industry as well. So these are folks that have worked in industry and then they help bring that information back into the university. So I suppose, through that entire consultation process to the whole inception of REEdI and what it was that we were trying to do to where we are right now, we have that framework validated. we have a Bachelor of Engineering, Mechanical and Manufacturing Engineering now, and it's coming into its 4th intake of students in September 2025. It's extremely successful, and we've doubled our intake across the last 3 years.
So it sounds like the output at the end is to get people that can think like engineers, as opposed to people with a very defined set of skills to be applied in the workforce. Well, was that something that you had in mind?
Definitely. You can have the technical skills, but you need to be able to, I suppose those are the skills, problem solving, troubleshooting, organizational skills, being comfortable with ambiguity, not necessarily knowing the solution to a problem straight away, but how you take that problem, you break it down and you try and understand the root cause of it and try and come up with a solution to the problem. So the technical side is obviously very, very important to us, but it's all those other things and how you bring them together to help. And a lot of it is about, how you solve. It is about how you solve problems, and that was very, very important to us. And to have students comfortable from the minute they come in, that's how they're going to be learning. They're going to be learning in projects where the solution is not always going to be apparent, and they have to work together as a team to come up with the solution. And that can be a little bit daunting coming in into university in year 1. The first day you're hitting project challenges and teams.
And to talk about that day one experience, of course, engineering is such a broad area of endeavour, either at academic or applied level. How did you decide which elements to pull from to give students a broad appreciation of engineering as a career? Was it a case of, okay, let's work with pharma over here because it adds the following. Let's go with smart manufacturing over here because it's an entirely different perspective. How did you pick and choose that way?
Yeah, it was challenging. We had our portfolio of industry partners. They're across, as you mentioned, many different sectors of manufacturing. So pharma, agri-tech, food, general manufacturing, electronics. So really what we want to look at it initially from the manufacturing engineering perspective. So if you take manufacturing engineering as a discipline, and then when we consulted with industry, we came up with, what are the learning, the main outcomes or that a graduate manufacturing engineer needs to be able to, or the graduate attributes. And we also looked at, okay, is it manufacturing, or is there also other elements of engineering in here that we can look at? And manufacturing mechanical were universal across all of the industries that we were looking at, and they were the type of graduates that our industry partners were looking for. Now, in addition to that, what we also did is we did an exercise, and we have this actually on our website, a career pathway planning, where we look at all the different engineering roles in the manufacturing sector, and we've mapped them to the different modules that we have designed and developed with our industry partners. So it is a degree in mechanical and manufacturing engineering, but what we've also done, it's all about the line of sight to jobs, because that's something that we found is very, very important is, you can have a degree, you can have a title, but really do students know coming in what they're going to be doing on a day-to-day basis when they graduate? So we have a spectrum from mechanical engineer, manufacturing engineer, and all the different roles as well, from quality, production, process, validation, project engineers, all within that. And we have mapped our program to how you can, the learning outcomes of all the modules and the program, how you can actually work and apply these in all of these different engineering roles. So it was very much starting with the manufacturing side and then going, right, well, what are the different roles that a person could work in with this degree as well? And even the titling of the degree was very important to us. So that was done very much in consultation with our industry partners across that broad range of companies and across the manufacturing sector.
That issue of having the career path in place, I mean, people think of engineering, they imagine a very linear career progression. Was that something that you thought was very important in winning students over, that, people can understand what the career of an engineer looks like, but also the gaps in the market for where the most jobs might be as well?
Definitely. I think there's a couple of things, it's very important, especially for, females in engineering, to have role models. That's amazing. And that's what we need. And we're doing huge work around that. But I think as important is the job that they're doing and what that job looks like and what it is on a day-to-day basis, and what are the, what can that job get you as well, in terms of, what's very important is, financial rewards. Engineering is a very, very well paid career, and to, be able to communicate that to, people when they're thinking about an engineering course and an engineering career. Also the different, I suppose, paths there is. As I mentioned, we've mapped our program to so many different engineering roles, but to show that diversity and that choice and that variability and where your career can go from a technical path to even a leadership path to an education path. There's so many things you can do in STEM and specifically in engineering that that is really important to be able to communicate and show that to people thinking about studying engineering, and also for a career in engineering as well, because it's about 24% of people females study engineering, but then only 1 in 10 end up working in engineering. So it's really about making sure you have that connection between coming into an engineering course, coming out of it, going into the workforce and what that looks like, and to have a very clear kind of idea. Within reason, you can't map absolutely everything out, but to show where you can go, the pay that's there, the variety that's there, the opportunity to travel, the flexibility that these careers offer as well. So I think it's very important to be able to communicate that to people when they're thinking about a course in engineering.
Yeah, so let's take a step back chronologically there. You raised the issue of getting more girls involved in engineering. In your experience and outreach, how have you found girls to be receptive to the idea of a career in engineering? Because as we know, uptake in STEM subjects tends to be quite healthy up to junior cycle, but then for various reasons, either parental expectations or social pressure, it becomes much more sort of siloed into biology, which might be considered sort of a softer science. So how have you found that receptiveness to looking at engineering and making sure that continues from junior cycle all the way up to leaving cert level?
Yeah, I think there's a number of different things to probably unpack there. I think some of it comes down to, the subject choice. So, and it's not only be for girls, it could also be for boys as well. The misconception that you need to have studied engineering, for example, for your leaving cert to do engineering at university. So I think that is a misconception. But then, while you don't have to have studied it, choice is a factor as well. So, there is, I think it's only 60 something % of girls' schools that offer the likes of engineering, DCG, construction studies as a subject choice. So that is a big consideration, and that's a barrier when we go out and we're, promoting engineering and doing our outreach and education activities, that the choice isn't there for girls that want to study engineering. The other side of it is, as well as the expectation that, you have to be the maths genius. You have to be an honours A-level maths person to be able to do an engineering program, and that is not the case at all. As I mentioned, like the role models, that's also, a lot of girls maybe don't know someone that's working in engineering. They don't know the types of jobs that you can have. They don't know the benefits that are there. So I think they're kind of the things that generally we see, and it's about kind of showing, giving the answers to those kind of the answers to those questions, or, helping to, show and communicate the different opportunities that are there in engineering. And I suppose there is a stereotype there that it's a male dominated or more male suited career, because it is male dominated. There's more men working in engineering, but that's a male suited career, and that's not the case. I think you still have that misconception of, oh gosh, I'm going to be working on a building site, I'm going to be working with heavy machinery, or I'm going to be doing, sitting doing calculations, or that's not the case. There's so many different career choices that you can avail of. But they're the things, I think, the stereotypical, male-suited career, the lack of role models, the lack of information about the jobs, the subject choice that's available at second level. Now, what we've done with our entry requirements for our program as well, we've tried to open up the accessibility to engineering as well. So it's not all about CAO points to get onto our program. We have a portfolio as well. So students get equal weighting for their CAO and their portfolio. So we actually had our portfolio webinar for CAO intake last night, and it's not an engineering portfolio we're looking for. It's not a DCG portfolio. It's really about showing us why you like problem solving. Giving us an example of a project that you've done. It doesn't have to be, as I said, an engineering or even STEM project. How you come up, found a problem, solved the problem. What did you learn? Why you think you'd maybe like to study engineering. And, that gives students a different opportunity as well to access an engineering degree and to gain extra points as well. So
you've kind of leaned into the use of emerging technologies, in particular blended reality. Tell me a little bit about how that came to be such an important part of REEdI.
Yeah. That journey probably started back in 2018 when I moved from Cork back to Kerry, and I got a role managing a regional enterprise development funded company called ACE, and it was a collaboration with Enterprise Ireland, Kerry County Council, Munster Technological University, and 3 Tier 1 agri-tech companies. And the vision with that company was to set up a hub of excellence for virtual reality, augmented reality training for people working in the agri-tech manufacturing space. So as part of that initiative, we actually set up a virtual reality suite at MTU Kerry campus. So it was one of the first in Ireland, and it's a really, really impressive facility in that VR suite. We have a suite of mobile VR equipment, and it was all about, how we can improve training and development of staff in manufacturing companies. So that was kind of the starting point. And then when we started looking, externally, what were best in class in terms of engineering education programs, we already had the expertise here with the ACE suite and what we had set up at MTU Kerry campus. And we looked at that and looked internationally. Was anybody using VR, from a research perspective, actually using it operationally, to use the term, in the degree as a key learning, in their degrees as a key learning tool? And they weren't. But yet our industry partners were actually saying to us, we need people to be able to use this technology when they're in manufacturing, where we need people that are skilled in using VR and AR. So when we were designing the program with our industry partners, we said, right, well, we look to see, can we embed VR and AR as a key learning tool from day one? So in order to be able to do that, we said, right, well, everybody needs to have access to a VR headset. This needs to be truly integrated into the curriculum, not just a token. So we have about 60% of our program has got VR technology or AR technology integrated into it. So what that means is every student, when they register on our program, they get an Oculus Quest headset, and they use the headset for their project challenges from day one. They get a very in-depth technology induction as well. So they're not just given the headset and away you go. They're trained how to use it, and they use the headset then for engineering challenges and projects from semester one. So it started back in 2018, 2019 with the setup of the facilities that we have. And then as we migrated towards the REEdI project and the opportunities there and the consultation with our industry partners, it became apparent that it really was something that we needed our students to be able to natively interact with. And I suppose a key point as well, it's a technology that's been around for quite a while, but it's emerging now as kind of mainstream in manufacturing. But our students, the skills that they have gained in terms of being able to use the technology, troubleshoot it, apply it, they're skills that they can use for any emerging technology that comes into industry. And it really gives them a really good toolkit, for when they go out into work placement, that they have been able to adapt and adopt to using this type of technology.
You've mentioned the importance of industry partners there a few times. How much are they involved in deciding the content of the program, or providing feedback, or going, look, these are skills that we need that we're not actually getting at the moment. Can you have a look at integrating them into the program?
Hugely involved. They are involved from the beginning in terms of the design. So looking at, okay, what do our student engineers need to learn? And how do we make sure that we are assessing them, that they're demonstrating competence? So it's very much they're there right at the table and figuring it out from the beginning with us. In terms of how they actually then, when we've designed the program, we've developed it, it's going through what we call the validation process. So that's where it goes through the academic rigor to make sure that it meets all the standards that's required. We have industry also on validation panels. So industry that maybe weren't involved with us in the design and development. So other industry folks then would be on the panel, and they would vet it and make sure that it meets the requirements of industry as well. So that's from the validation side. And then after that, we have continuous improvement meetings with our partners as well, where we say, right, well, is there any parts of this that we can improve, any parts of the modules, the programs, and we build that back into kind of feedback loop. That's the management of it. But then in the day-to-day delivery, we have guest lecturers from industry that come in and they would deliver on the program as well. So that's extremely valuable because they get to talk about specific engineering pieces, but they also get to talk about their company and the role that they do. And that's a great insight for student engineers in the program with us. They also, we have our students going out on taster days, it's called. So again, from semester one, year one on our program, our student engineers get to go on taster days to our industry partners. So they get to walk manufacturing lines, they get to talk to all the different types of engineers, they get to see the types of companies that they're going to be working in year 3 of the programme. So they're going to be on a paid work placement in year 3 and 4. So really from semester 1, they're getting that insight into the companies that they can work in, the types of engineering roles that they can work in the company. And it's extremely, extremely valuable from the very, very outset. So from the industry side, they are key. We also have coaching and mentoring programs that we run with our industry partners so that they're set up for success as well when our student engineers are out on work placement. And then there's also that two-way, knowledge exchange. We have industry professionals teaching on the program as well. They've come into academia from industry back in 2020, 2021. But also to make sure that they stay up to date on the developments that's going on in industry. There's that two-way knowledge exchange. We have people coming in from industry sharing experience. And then from the research centre side, I'm part of the IMR Research Centre, and we can offer our industry partners then a lot of experience when it comes to, research projects and going after collaborative research funding as well. So it's an extremely beneficial partnership for industries to be involved with REEdI and the IMR Research Centre at MTU.
So looking forward into the future then, are there any particular developments happening either at a national or an international level that you're thinking that would be a great addition to our programme?
Yeah, I suppose there's a number of different things happening at the moment. We were very lucky just before Christmas to be awarded additional funding to scale our model further. So what that means for us is that we're going to be starting this year to add an additional stream from our BEng in mechanical manufacturing engineering to focus on meeting skills needs of the offshore wind energy sector for Ireland. So that's a really, really exciting development for us as well. We have developed an engineering network internationally as well. So we're part of a network with Aalborg University College London, where we are constantly benchmarking what it is that what we're doing and how we can improve. But I suppose for the next 12 to 18 months, our focus now is on, validating that additional stream from the REEdI BEng to meet the needs of the offshore wind energy sector in Ireland, and obviously to maintain and grow our student numbers and our female numbers on the programme and continue our outreach activity.
And that was Dr. Fiona Boyle, Director of REEdI and Head of Department STEM at MTU's Kerry campus, chatting with Niall Kitson.
Remember, you can get the latest Irish tech news with hourly updates, daily newsletters, and more at our website, techcentral.ie. Share the knowledge and invite a friend to listen. Search Apple, Spotify, or YouTube for TechRadio Ireland, or listen with RTE Radio 1 Extra. TechRadio is produced by dustpod.io for techcentral.ie. From me, Artemis, live long and prosper.